Hello students, welcome back. We'll have to get back to modeling problems, but let's review the theory part again. Here was a motivating example problem that we went through earlier, but let me talk about the typical structure first. See, this was just an example, but more typically we are looking for this kind of form. Ax plus by is equal to a certain number, capital A, and a cx plus dy is equal to another number, say capital B. This is a kind of structure. But this is a little bit too general. Very frequently, you're going to have much simpler expression like this, yet still hard enough for students. And this is a kind of problem that most students will have to focus upon. Alright, there's some really good student here who wants to cover everything like blanket. In that case, alright, this one too. And then of course, heck of a lot of other things too. But for normal level students, you really want mastery on this type. There gotta be x plus y equals to b somewhere. And then look for ax plus by equals to something else. And these numbers right inside, capital A and capital B, they're mostly given from the problem or just elementary manipulation. The left-hand side come from typical structure. Alright. Let's go to the next example here. We talked about coffee example already. So let's go to the next example and let me get some bigger font. The manager of Starbucks store decided to experiment with a new blend of coffee. She will mix some B-grade Colombian coffee that sells for $5 per pound with some A-grade Arabica coffee that sells $10 per pound to get 100 pounds of new blend. The selling price of the new blend is to be $7 per pound, and there's to be no difference in revenue between selling the new blend and selling the other type separately. How many pounds of B-grade Colombian and how many pounds of A-grade Arabica coffee are required? Okay, alright, how do you set up? Well, first a variable. We are looking for some blends of coffees in pounds. So why don't I select Colombian as X and then Arabica as Y? Or if you prefer B grade for B and A grade for A, that's fine. Or Colombian for C and Arabica for A, that's fine. You can do various things, but, well, in the previous problem, especially when I was looking for the structure, I used XY, so I'd like to stick to X, Y, and Y. So X is Colombian and Y is Arabica. And then X plus Y, does this appear somewhere? X plus Y. You see, remember, X plus Y and then AX plus BY. X plus Y. Weight of Colombian and Arabica put together, total. Well, there are some numbers given here. And $5 per pound, what is that for? $10 per pound. And then 100 pound. And then $7 per pound. Yeah, there are many numbers there. Which one corresponds to equals to something? Equals to capital A, equals to capital B, those kind of things. Is this clear to everybody? X plus Y is equal to 100. Is that clear to everybody? X is Colombian, Y is Arabica, and they add up to total 100 pound. You see? Let's start from the structure. X plus Y equals to something. AX plus BY is something else. Why am I having this font problem here? Okay, that's better. Okay. And X plus Y, is that clear that X plus Y is 100? Okay, alright, that's 100. Okay, alright. And then how about ax plus by? What is that? Well, you have to look at the other units, I guess. In terms of pounds, x plus y, and then all the others are about dollars. $5 per pound and $10 per pound. Which one goes to x and which one goes to y? $5 per pound, is that Arabica or is that Colombian? $10 per pound, is that Arabica or Colombian? With the problem. And then you will see this is 5x plus 10y. 10 is for Arabica, and then 5 is for Colombian B grade. And then equals to what? Dollar amount. Once you get that, then the setup is complete. Well, any idea? Well, all right. Here's the answer. 700. $7 and 700. $7 per pound and 100 pounds. So I'm using this one. So we have x plus y added to 100 pounds. That's easy. And we need ax plus by. And ax plus by, look at the unit. I look for dollars here. $5, $10, and make this one into dollar. And 5 times weight so that we get dollar amount. 10 times weight so that we get dollar amount. Do the same thing. $7 per pound and then multiply by total weight, 700. Solving the system of equations, that's the easy part. So for one variable, I decide to solve for y equals 100 minus x, and then plug it in right here. Right there. Oh, no. I used first equation, so you have to use the second equation right there. 100 minus x in there. Break out the parentheses, and then you have it. These are not difficult computation. We get x equal to 60. All right. 60 pounds belong to B grade Colombian out of total 100. Subtract and you get Arabica. Or you can just plug into this equation. You don't really have to go back to the problem if you do it that way. Again, let me emphasize. Most of the time, unless the problem is super hard, there gotta be x plus y somewhere. X plus y equals to something. And that'll reduce the problem tremendously. So we went through 2 problems like those. Interest rate problems. Previous problem in separate video. Let's see. CD plus corporate bond. The key was x plus y equals to something. And then ax plus by. What is it? Now let's go to a little bit harder problem here. A motorboat heads upstream a distance of 24 miles on a river, whose current is running at constantly 3 miles per hour. The trip up and back takes 6 hours, assuming that motorboat maintains a constant speed relative to water. What is the speed? That's a question. Oh, that's a little bit harder. Let's see. Distance of 20 miles total, and then total 6 hours. So these two must have something to do with the capital and capital B, but excuse me, I just missaid it. 24 is not total, excuse me, it's not total. Upstream is 24, downstream is another 24, it's not total. Oh, that gives you an idea. This cannot be x plus y. Get an idea? You see? This is not the total distance of travel, okay? It's just upstream 24, downstream 24. Total is this one. Trip up and back takes 6 hours. There are other numbers to look at. 3 miles per hour, but that's clearly a rate. Look at the unit, miles per hour. So that's the rate. So that's not the right hand side, capital A and capital B. So it's got to be either this or that, but it's got to be this. So let's set it up like this. X plus y is equal to 6. Are you with me? where x is, what is x? Total time takes 6 hours, so x is travel time upstream, y is travel time downstream. Let's set it up like this. And then they add up to 6. Okay, alright. How about ax plus by? But did I tell you this problem is harder? Yes, it is harder. And this problem is not directly asking you to find out, let's see, how much time did it take to go up and down? It is asking you the speed of the boat. So another variable is coming into play. So how do you set it up? Well, okay, let's sort of like this. What is the speed of boat? Of the boat. Okay, let's set up like this. And will that help you working with 24 miles? 24 miles upstream. So speed of the boat times the time, x, will give you 24. So speed times the time is gonna be 24, but this is wrong. Why? Upstream, you do not go the speed of the boat. Because of the running water, I have to go a little bit slow. Downstream, faster. Downstream is faster. I go 3 miles per hour faster than the speed of the boat. So what do we have? Time, and then speed. We need 3. We have 3 unknowns, so we need 3 equations. And then how do we set it up? Well, let's see. We have to use this, x plus y equals to 6. So that's what we are going to do. So for x, so for y, x is equal to 24 over v minus 3, and y is equal to 24 over v plus 3. And then if we plug this one into, x plus y is equal to 6. And finally, we are going to get something. (24 over v minus 3 plus 24 over v plus 3 is equal to 6. And what do we have? We have an equation, and it is likely to be a quadratic equation, and the standard process applies. What's the standard process? Number 1, denominator. Number 2, parentheses. Number 3, like terms. Remove the denominators first by multiplying something strategic. And then no denominator, gone, poof. And then you'll have parentheses coming from, well, hidden parentheses. Whenever you have big horizontal bar, there are parentheses hidden, you see. So you will have hidden parentheses, so you have to remove the parentheses. Remember again, denominator, parentheses, like terms. Denominator first, remove those by multiplying something to each term, which I'm not telling you. And then break up those parentheses, and then take the like terms together. You're going to get something. You're going to get relatively simple quadratic equation, and you're going to get appropriate answers. I'm not telling you anymore. I'm not showing you anymore. I'm stopping here. I'm going to ask you to finish. As a matter of fact, this problem came from the textbook as the example problems, so you can read through the textbook if you want to, if you're really stuck. But me, I'm going to stop here.